Hi guys, welcome back to Signals and Systems Lab Experiment 4. This is Agram roll number 19EC01018. In this experiment we are going to discuss about the function for convolving two signals and for plotting the output of convolved signals with the given impulse response and given signals, and discuss the properties of given systems. So first of all, we are given these four systems. You can clearly see them. So if we observe, as the given systems are discrete and the impulse response for the first system is 1 by 3 comma 1 by 3 comma 1 by 3, and for the second system is an array of size m, and the element of the magnitude of each element is 1 by m, and for the third system impulse response is 1 comma minus 1, and for the fourth system impulse response is 1 by 2 comma 0 comma minus 1 by 2. So here next we need to study the performance of above systems. So for that we are given some codes. So first of all, let us plot the given signals. So these are the given signals. So I have ran the code. So here you can see the four signals. So the first signal contains a unique trend, whereas the remaining three signals are same, but here the difference between these signals is increasing noises, which makes the signal disturbances. So here you can see when I zoom the graph, so you can see the fluctuations. As we go down, the fluctuations are increased, which makes the noises in these three signals are increasing in an ascending order. So here, so this is the function for convolving two signals, where x of n is my input signal, h of n is my impulse response. So here I have used two for loops for convolving the two signals. So this is the code. So here for the system 1, initially I loaded all the input signals, and here, as I said before, the impulse response is 1 by 3 comma 1 by 3 comma 1 by 3. So here I have convolved the four signals with the impulse response for getting the output. So here I have plotted the signals. So I run the program. So you can clearly see that the output of the signal is not much varied, but here the disturbance are decreased when compared to the input signal. So here for the signal 3 and signal 4, the fluctuations are decreased, which means the noises are decreased. So thus the noises are decreased. And by seeing the output, we can clearly say the given system is a low pass filter, and by looking at the system, it is a moving average filter. As the impulse response are finite, the sum of impulse response finite is a stable system, and as in given in the question, it is a linear time invariant system. So now for system 2. So for system 2, we, as I said, we are given three values for the output depends on the value of m, as the impulse response changes with the value of m. So here initially I am giving a value of m as 25. So here you can clearly see that the disturbances are almost zero for these signals, which means this is a more fine filter than the system 1. It is also a moving average low pass filter. So here you can see that output for the baseline filter, which still it contains the trend line. So now again I will run the program and change the value to 100. So here the output for each signal is almost changed, so that as the impulse response is here, so the convolved signal completely depends on the value of n here. Now for the third system, as we had discussed before, the impulse response 1 comma minus 1, I have used the same step when I run this program. So here, unlike systems 1 and 2, here we can clearly observe that the disturbances have increased. So when I zoom the curve, initially the input signal 1 has zero disturbances and there are no fluctuations, but here we can clearly observe the fluctuations has increased, so that the noise in the signal is increased. By this we can say that the system 3 is a noise adding system, and it is a by looking at it, it is a differencing system with which is a high pass filter. So when we run the system code. So here also the disturbance are increased. So this system is almost similar to the system 4 as you can see given. So here the systems 1 and 2 are moving average filters which are low pass filters, and these 3 and 4 are differencing high pass filters. Now here you can see the noise is added in the system 4. So here trend. The trend in the system is nothing. So here trend, if X is the input signal and Y is the convolved output signal, then the trend removed signal is nothing but capital X equal to the input signal minus the convolved signal. So here, as we discussed before, the first signal which is baseline PPG contains the trend line. So here I has convolved the signal, and let L be the length of the convolved signal, and I considered X as the zeros of 1, 1. So to match the length of the matrix, I have considered the remaining elements of X, the input signal as zeros. So here I have used for loop for finding the trend removed signal. So here X of A equal to X of B2 minus Y. So when I run this program, so initially I am considering the value of M as 100. So in this output we can clearly see that the trend in the red color line, which is the convolved signal, is the trend signal, and blue is the input signal. So here the trend removed signal is almost in, but here as we are unable to find this, but there is a lot of difference between these two signals. For example, the magnitude at 600 peak is in the trend not removed signal, in the inputs initially is 0.9553, but in the trend removed signal is 0.6967, which means the somewhat value is decreased. So here, if again I will run the program and consider the value as 200. So for 200 also, the magnitude change on the trend line is somewhat different, but the trend is removed. So now I will plot the both the plots in the same plot. So I am plotting both the trend removed signal and the input signal in the same plot, so in the same graph. So when I run the program, so here we can clearly see the difference between the input signal and the trend removed signal. Here blue color line is the trend input signal, red is the trend line, and the yellow color shows the trend removed signal. So this. Now here, when we come on to the properties, causality means if the function depends on the previous input and output values of the signal. So here the first system depends on the previous input value, so the system 1 is causal, and the second system also depends on the previous input value, so it is also causal, and the third system also depends on input. So all the systems are causal. Stability means the sum of impulse response should be finite. So here, as we had discussed, all the impulse response for all the systems are finite, so all the systems are stable. As given in the question, all the systems are linearly time invariant systems. So when it comes to memory, so memory means if the system depends on the previous inputs and outputs of the system. So everything depends on the previous input, so every system can be considered as a memory system. Thank you.